Hi, I'm going to show you how POM-QM does crashing of projects. In my course documents under handouts, I have a Word document that is called Crashing Dissection. Here is a document, and I know that it's several pages long, but reading it and studying it page by page is going to be very beneficial to you in terms of getting across the point of what is crashing and how our activities crashed in order to reduce project time. Essentially, it has to do with looking at the critical path and picking critical activities that have the least cost to be crashed so that we can reduce project time. Here's a project that we're going to work with. This is from the handouts, and then I also have the POM-QM solution for it, and hopefully we can track between these two files. If you were to solve this problem using normal times, you will get 21 weeks of project time. We have the immediate predecessors for each of these activities. We have normal times, normal cost, crash cost. So activity A, under normal times, if we were to do it under normal circumstances, it would take 3 weeks and it would cost us $900. But if I want to allocate more money to that activity by spending $1,700, I can actually get it done in 1 week. So going from $900 to $1,700, that's an additional $800 of expenditure, but that will reduce A from 3 weeks to 1 week. So 800 divided by 2 weeks that we save in terms of time is going to be $400 of crash cost per week. Similarly, B, normally we can do it in 6 weeks and it would cost us $2,000, but if I want to get it done in 3 weeks, it will cost me $4,000. So the additional $2,000 of cost divided by the 3 weeks that I'm going to save will be $667, and so on and so forth. So if I were to solve this problem using normal times, using POM-QM, all the data in here has been entered using the crashing option of project management. But I can very easily change the method here to single times, and so now that normal times are used, and if I solve it, I get 21. I get 21 as the project time. So I know that this project is going to take 21 weeks to complete if I am to do it under with normal times. The critical activities are B, D, E, F, and H, and it's going to take me 21 weeks to finish this project. Now I can go back to the crashing. I can edit and go back to crashing and solve this problem, and I will get this result right here. Let's understand this. It says that I can finish this project under normal times. Project time under normal times is 21 weeks, but I can get it done in only 12 weeks. What does it take for me to do it in 12 weeks? Well, I need to crash activity A 2 weeks, B 3 weeks. I don't have to crash activity C. D must be crashed 2 weeks, E must be crashed 1 week, F 2 weeks, G 2 weeks, and H 1 weeks. If I'm to do it under normal times, 21 weeks, it's going to cost me $18,700. But if I want to get it done in 12 weeks, it will be an additional $6,370 over and above the $18,700. So to get it done in 12 weeks, it will be the summation of these two numbers, which I believe is $25,070. Now, activity A normally can be done in 3 weeks, but I could crash it down and get it done in just 1 week. And it looks like I will need to crash it those 2 weeks, which is allowed, going from 3 to 1. That's 2 weeks of crashing allowed, and it looks like I will have to crash that activity by 2 weeks. It will cost me 2 times 400, $800 to crash activity A if I want to finish this project in 12 weeks. So similarly, all of these numbers listed in blue are what I need to do in order to crash the project from 21 weeks to 12 weeks. The numbers in black is what I entered. This column right here, cost of crashing per period, is what the software generates, but we already discussed how that is generated. It's essentially like this 400 is the 800 additional cost divided by 2 weeks of crashing that time saving that I'm going to earn, and so it's 400. This 18,700 is what the software generates, and that tells me that at the minimum this project is going to cost me $18,700, but if I want to crash it, it'll cost me, of course, extra. Activity, let's understand these entries down here. Activity C, for instance, under normal times it can be done in 2 weeks. I could spend money on it, and instead of costing me $500, I could spend $1,000 so that I can finish it in 1 week. But it's not necessary. Look, if I want to crash this project and finish it in 12 weeks, C must not be crashed because it has a 0 under it, and therefore there is no cost of crashing associated with activity C. Let's go to here. For instance, activity G normally would take 9 weeks, but I could do it in as low as 4 weeks. So there's 5 weeks of crashing that is allowed, but I will only need to crash it 2 weeks. 2 times 360 is 720. So to crash this project in 12 weeks, the cost of crashing only is 6,370. The normal cost is 18,700. Now, what does it take, period by period, so that we can get it done in 12 weeks? That information is in the next table, but let me summarize here. This table right here, which is called the project management results, that's the first window that pops up when you solve. It gives you the summary of crashing. Essentially, the 12 is the lowest number of weeks that is required to finish this project, and these 2 columns right here tell us the details of how to get the project done in 12 weeks. Now, I'm going to reduce the font a little bit and crush it, or make the column smaller. And let me go ahead and bring up the crashing window. And here's the crash schedule window. And I'm going to crunch this up to cumulative cost. And I'm going to fit that right next to this other window. All right. So, by the way, this is showing to 10,000ths, but I can change that to 2 decimals. All right. The crash schedule tells us the details of the crashing. To get this project done so that the project time takes only 21 weeks, there is no crashing cost involved. That's what it's going to cost us at 21 weeks. It's going to cost us only 18,700. That's the normal cost.
But what if I want to go, and notice over here that this row is blank all the way throughout that row. But to go from 20